Alright, in this session we are going to continue the topic vectors, and we are going to start a new exercise in which we are going to discuss about constant velocity problems. Now we know very well that the working formula for velocity is displacement over time. Alright. Before starting the exercise, there is an example, so you will have an idea that what are we going to solve in this exercise. It says an object travels at a constant velocity from point A to point B. The distance or the displacement of AB is 32I minus 24J. So we have the value of displacement, and it's 32I minus 24J. And the time taken is 4 seconds, so you have time as well because it goes to 4 seconds. In the first part, we need to find out the velocity. Alright, so what is given? It says meter, right? That means we have given a displacement here. To find out velocity, the working formula as mentioned here, it's displacement divided by time. The value of displacement we have is 32I minus 24J, and the value of time we have is 4 seconds. In the numerator, we can take common here, and that will be 4. So if you take 4 common, so inside the bracket it will be 8I minus 6J divided by 4. Now you can cancel out these two 4 here, and the leftover part is your answer, that is equals to 8I minus 6J is equals to velocity. Alright, once you have the expression for velocity, we need to find out the speed, right? The speed is what? The speed is basically the magnitude of the velocity, alright, and that will be 8 square plus 6 square. If you say minus 6 square, so that will be also 36. 8 square is 64 plus minus 6 square is 36, leads to 100. Root of 100 you have, it's 10. So the speed is 10 and the velocity is 8I minus 6J. Keep in mind, whenever you talk about velocity, you need a direction to define it. And the values of I and J are basically the notation of direction. So, and for a speed, there is no need for direction, you only need a magnitude to define a speed. Alright. So I hope that this example is clear to you, and after that we are going to start the exercise. It's exercise 13.4. Exercise 13.4, and it's question number 1. We have 3 parts. The first one, it says displacement is given, time is given, find the velocity. So that is very similar question we have done in the example. So first we need to give it a try, and for this part we have a time of 3 minutes to give it a try, so start. Alright. So velocity is what? Velocity is displacement over time. Displacement you have 21I plus 54J divided by 6. If you take common in the numerator, so that will be 3. Inside the bracket it's 7I plus 3 1s are 3, 24, 3 8s are 24, 18J divided by 6. So you can say that 3 1s are 3, 3 2s are 6, that will be 7 over 2I plus 18 over 2, that will be 9J. Alright, that is your velocity expression. 7 upon 2I plus 18 over 2, that means it's 9J. Alright. After that, for part B, that is all for part A, because we need only velocity, not the speed. If it talks about speed, then you need to find out the magnitude of this expression, right? After that, part B, it says velocity is 5I minus 6J. Alright, velocity is given and time is given 6 seconds. So with the help of these two, you need to find out displacement. We are going to apply the same working formula as mentioned here, this one. Alright. So with the help of this working formula, can you find out the displacement by yourself? First give it a try. We have a time of 2 minutes and then I will explain, so start. Alright. We know that velocity multiplied by time is equals to displacement. The value of velocity we have, it's 5I minus 6j, and the value of time we have, it's 6. When you multiply these two, 6 5s are 30I minus 6 6 are 36j is equals to displacement, and that is your answer. Alright, and easy parts after that, part C. In part C, it says velocity is negative 4I plus 4j. Velocity is minus 4I plus 4j, and you have kilometers per hour. Displacement is minus 50I plus 50j, and it's kilometers. You need to find out the time here. Alright. With the same application of this working formula, you need to find it by yourself first, and time is 2 minutes, so start. Alright, so basically time is equals to displacement divided by velocity. Displacement we have minus 50I plus 50j divided by velocity we have minus 4I plus 4j. From the numerator you can take common, and that is 50. Alright, so inside the bracket it's minus I plus j. If you talk about time, that minus 4 is common here, and inside the bracket, no, plus 4, sorry, not minus 4, plus 4 is common, and inside the bracket it's minus I plus j. If you observe that these two brackets are same, minus I plus j, so we can eliminate these two brackets, so they are cancelled. And the leftover part is 15 divided by 4. If you solve it, that will be 25 divided by 2 leads to 12.5, and the unit is hours this time. Why it is hours? Because speed is given in hours. And it also verifies because time does not require any direction. That is why the I and j component are cancelled in this part, because time is independent on the direction. Alright, moving on towards the next question. It's question number 3. Alright, the question says a helicopter flies from a point P with a position vector of 50I plus 100j to a point Q. The helicopter flies with a constant velocity of 30I minus 40j and takes 5 hours to complete the journey. Find the position vector of Q. Alright. So you have the position of helicopter, that means the position of P, and it's 50I plus 100j kilometers. Alright, that is the position of helicopter. The helicopter flies with a constant velocity of 30I minus 40j and takes 2.5 hours to complete the journey. Time is 2.5 hours, and velocity we have it's kilometers per hour. Alright, and we need to find out the position of the helicopter now. Before explaining this question, let me give you one example here. Let's suppose that Mr. A is standing at a point. Alright, so it's Mr. A. Currently his position is, let's suppose that is the home of Mr. A, right? Currently I am saying that Mr. A is 5 meters away from his home. Alright, After that, Mr. A starts to travel, and he traveled a distance of 15 meters, and now he is standing at this point. That is Mr. A. So if I'm asking you that what is the position of Mr. A with respect to his home, so you will say at starting point he was 5 meter away, and after a while he is 15 meter away. That means he is 20 meter away from his home. It makes sense, right? So basically what we are going to do to find out the final position of any object, what we are going to do, the original position of that object plus the distance traveled with respect to or from velocity. Distance from velocity, you need to add them, right? Mr. A was standing here, he moves a distance of 15 meter because so that we can say that this distance covered with the help of velocity. Alright, now if I relate the same example to my question, so what I will say that we are looking for the final position of helicopter, right? We know the initial position, that is IP, initial position of helicopter plus distance or displacement traveled. Alright, the initial position of that helicopter and the displacement traveled, we need to add them to find out the final position. The initial position as given, it was the point P, which is 50 I and 100 J. That is the initial position plus. Now we need to find out the displacement, and if you all remember, so displacement is what? Displacement is velocity times time. Alright, that is the displacement. So we have the velocity is 30 I minus 40 J. Velocity times time is what? Time is 2.5 hours. Alright, so that is that portion of displacement which the helicopter covered with the help of velocity. Alright class, now we need to multiply here, so 50 and 100 as it is plus 30 into 2.5, 30 into 2.5, it's 75, and 40 into 2.5, it's 100. Alright, when you add these two, 50 plus 75, it's 125, 100 minus 100, 0. So that is the final position of the helicopter. Alright, that is the final position. Since the question given is in the form of I and J, so my final answer, it will be final position is equals to 125 I. That is the final answer, the final position of helicopter. Alright, so I hope this concept is clear to you. To apply this concept, similarly, remember this example that initial position plus displacement due to the factor of velocity, you need to add them to find out the final position. So now you need to write down the solution in your copy, and you have a time of 3 minutes to note it down, so start. Alright, moving on towards the next question. It's question number 4 from the same exercise, the first part. A car travels northeast. Now northeast defines the direction, or you can say angle, right? How is it so? For first part, that is our scale, right? It's north, south, west, east. If it says that northeast, that means it's in the between of these two, exactly in half, right? So that means this angle you have, it's 45, and this angle you have, it's 45, that is meant by northeast. Alright, a car travels northeast with a speed of 18 root 2. So we have the value, it's 18 times root 2 kilometers per hour. Find the velocity vector of the car. So you need to find out the velocity vector, and it means that you need to express your velocity in terms of I and j. That is meant by velocity vector. So it's very simple. Basically, I is what? I is the position on x-axis, right? And j is the position on y-axis. That is why it's very simple. So you need to find out the components. These terms we refer as components of velocity or components of any vector. And how you find that? It's very simple. Alright. If I complete the figure, so that means this is the x component, right? And it will be the y component. To explain you better, let me draw it separate diagram. Alright. That is my velocity, and the angle is 45, right? So basically the easiest part is we need to find out the x and y component. Let's suppose that is the velocity y component, alright? The magnitude you have, it's 18 under root 2. So how you are going to find the Vy if you have a 90 degree here? Now, obviously you can apply trigonometry here, right? With the help of trigonometry, you can apply a sine here. We can say that it's sine 45 is equals to opposite divided by hypotenuse, right? So when you simplify sine 45 times 18 under root 2, with the help of calculator you can solve it, and you will get velocity of y is equals to 18. Since it is on the y, that is why I am going to label it as 18j, right? Similarly, if we are looking for px here, x for the x component, again with the help of trigonometry, but now we are going to apply cos here. Cos 45 is equals to adjacent divided by hypotenuse. Since sine 45 and cos 45 both are equal, you will have velocity of x component is equals to 18 as well, and it will be 18i. Now the final answer of velocity, I can say that velocity is equals to 18i plus 18j, and the unit is, since it's kilometers per hour, given in the kilometer per hour, so the answer will be in kilometer per hour as well. That is your first part answer. Alright, so keep in mind that whenever it says about the components of any vector quantity, so you need to find out the x and y component easily by applying the trigonometry here. That is your first part. You need to write down first in your copy, and you have a time of 2 minutes, so start. Alright, after that part B. In part B it says a boat sails on a bearing. Now what is bearing? I hope all of you remember it, right? Bearing indicates the direction that the angle 30 degree is from the north. Alright, angle 30 degree from north in clockwise direction. With a speed of 20, find the velocity vector. So firstly, I will help you with the figure here. That is my coordinate axis, okay? And we have a velocity vector, right? The bearing given is 30 degree, 0, 3, 0. That means this angle we have is 30 degree. All right. The speed of boat is 20 kilometers per hour. the magnitude is 20. Alright. Again, you need to find out the x and the y component with the same method that I have explained you in the first part, and you need to give it a try first. For this part, we have a time of 3 minutes 30 seconds. So start. Alright. When you talk about the components, right? For the x and y components, that is my right angle triangle. If this angle is 30, that is given, so the leftover angle we have, it's 60. Alright. Now, for the x component, velocity x. For the x component, we are going to apply cos here, so it's cos 60 is equals to adjacent divided by hypotenuse, right? Cos 60 is 0.5 times 20, that will be 10. So the velocity on x-axis is equals to 10, but you need to mention 10 I here. Alright. Similarly, for the y component, we need to apply a sign here. So sine 60 is equals to, and this is velocity of y component, opposite divided by hypotenuse. 60 sine times 20. It leads to 17.32. Velocity of y is 17.32. Alright. Now the final answer for velocity is equals to 10 I plus 17.32 J n kilometers per hour. Alright, so I hope that this portion is clear to you. Moving on to the next one, it's part C. Now it says a plane flies, I'm printing part C here. A plane flies on a bearing of 240 with a speed of 100 meters per second. Find the velocity vector of the plane. So first you need to give it a try by yourself, and since bearing is given, so make sure that you are plotting the right diagram, right? So you have a time of 4 minutes to attempt this part. So start. Alright. Firstly, I will explain you the bearing here because that is very important. Alright. Angle 240 means it is greater than 180 and lesser than 240. So the position is in the third quadrant. That is the position, right? And why is it so? Because this angle, the bearing angle, this one, it's 240. Alright? We need to find out the velocity components of that plane. So it's very simple. This is the x component, velocity x, and this red one is the y component, velocity y. If I am talking about this angle here, so this angle is what? It will be 30, right? Because from the north till the third quadrant it's 270. So 270 minus 240, it's 30. I'm writing it right now. 270 minus 240, it's 30. Alright, now the components. For x component, again we are going to apply cos here. It will be not this one, it will be cos 30. Cos 30 is equals to adjacent divided by hypotenuse, and hypotenuse is what? It's in grid given in the question. Alright, so cos 30 times 100, it's 86.6. So velocity x is equals to 86.6 I. Alright, but the important thing here is about the direction. Since the velocity component is in the negative x-axis, so we are going to produce negative sign here. So that is the velocity x. Similarly, for velocity y, we need to apply sign here. That will be sine angle is 30 is equals to opposite divided by hypotenuse 100. Sine 30 times 100, it's 50. So velocity y is equals to 50 j, but again it will be minus 50 because y is also negative. So the final answer for velocity is minus 86.6 I minus 50j. That is your final answer. Make sure that you are focusing on the direction part. Alright, so I think that it is quite enough for today class. Inshallah, next session we are going to continue. So take care and Allah.